Hello, I welcome you all to this another interesting screencast. The problem reads: locate the centroid Z bar over the homogeneous solid formed by boring a hemispherical hole into the cylinder that is capped with a cone. This problem is coming from the Engineering Mechanics Statics Arts textbook, 13th edition by R.C. Hibbeler. So we have a homogeneous solid formed by creating a hole at the bottom, which is a hemispherical. That's in the cylinder, and on top it is kept with a cone. So I've been asked to find the centroid, which is the geometric center of this volume. Right, so centroids, what is a centroid? It's a geometric center. We have geometric centers of a line, geometric center of an area, geometric center of a volume. And if the material is homogeneous, as is the case, and by homogeneous we mean uh, the material properties at every point throughout the body of the material are the same, e.g. density, elastic Young's modulus, Poisson's ratio, and so on. So when the material is homogeneous, the centroid coincides with the center of mass. The centroid also coincides with the center of gravity if the medium through which the material is placed or behaving is uniform. If the gravitational field where the material is uniform, then the centroid coincides with the center of gravity. So let's go ahead and try to work on this particular problem. So I'm going to name the parts for this particular problem. I'll name them part by part so that it will be easier to work with. So let me start with a cone on top. This cone that I've just outlined in green, let me call it number 3. And then the cylinder, the whole cylinder, let me call it number 2. And this hemispherical portion, let me call it number 1, part 1. All right, so to start with, we're going to draw to indicate the centroidal locations for each one of these parts. So I'll start with this hemispherical hole. We are going to assume it is not a hole, but we know it is a hole. We'll give it a negative sign so that we are able to subtract it as we do the calculations. Okay, so imagine that is its centroidal position there, and it's equal to, let's say this is equal to z. Okay, let me make the pen a little bit thick. Z caret is equal to for the hemispherical is hemispherical or hemisphere, it is 3/8 r, and our r is 150, so it is 3/8 times 150, which gives us as 3 times 150 divided by 8. So this gives us a 56.25 millimeters. Okay, right? So we are done with the first one. This one, Z cubed bar 1. I need to indicate that. So let's go to the cylinder. For the cylinder, it will be half, somewhere there. Let's say it is somewhere there. Half is height. Half is height, somewhere there. Okay, great. So let's say it is somewhere there. So what do we call this one? This one, you call it Z cubed 2, and this one is going to be equal to the height of the cylinder is 400, therefore half this length is 200. Okay, and then finally the cone. Let's go to the cone. Let's say is centroid position is somewhere there. Okay, somewhere there. Yeah, and let me say I extend this line like this. Okay, and then I draw this line. Must come down nicely and come there like this. Alright, it didn't come so nicely. Okay, something like that. So this one we are calling it Z cubed 3. This is going to be equal to 400 plus 400 plus this one is what is the centroid position for a cone. For a cone, it's supposed to be h or h over 4, right, from the base. Is that so? Of course, you can check these in any standard textbook, or you can calculate them. So this is going to be, the height is 300, so it's 300 divided by 4. So what does this give us? Is 400 plus 300 divided by 4. So this gives us a 475 millimeters. Have I done everything correctly? Great. Don't forget, this one we need to give it a negative when we come to calculate the volume for the hemisphere. We need to give it a negative. So let's start with volume 1. What is volume for hemisphere? Okay, volume 1 for hemisphere is going to be equal to 2 over 3 pi r cubed, which is equal to 2 over 3 pi times 150 cubed. Okay, should I convert them to meters? I think so. Those will be, I can leave them, it's no big deal. Okay, let me see how big this is going to be. Cubed. Oh no, it's too big, right? Let me convert them to meters. So let me say this one by 0.15. Okay, 0.15. So 0.15 cubed times pi times 2 divided by 3. Again, it's too small, right? It's too much in decimals. I think I'll leave it as just 150. Okay, 150 cubed times pi times 2 divided by 3. Okay, so this is equal to 7 7,768 583.47, right? So 2 over 3 times pi times 150 cubed, 70, 68, 3.47. This is millimeter cubed. So this is going to be negative. We shouldn't forget that volume of a cylinder, that is pi r squared h. So we have pi, and the radius, of course, is 150 squared. The height is 400, and then this gives us 150 squared times 400 times pi. What do we have? Okay, very huge number, 28,274,333.88 millimeter cubed. Okay, very big number. Let me just check this again in case I made an error. 28, 27, 43, 33.88. Great. Then volume 3, this cone, what's the formula for the volume of a cone? Is 1, right? 1 over 3 pi r squared h, right? So 1 over 3 pi times, what's the radius? Radius is the same as 150 squared. And what's the height? The height is 300. What we get is 1 over 3 times pi times 150 squared times 300. So we have 7068 7068. How come we have 7068 583.47? How come we have the first similar to the other one? Okay. R we said is so the other one was 2 divided by 3 times pi times 150 cubed. We have the same answer. And then this one, I'm talking about volume 1 and volume 3. They are the same, right? Okay, I think so. That is that should be fine. That should be fine. Okay, I get it. It's okay because of the 2 there. Alright. So they have the same volume. So we move on. So having found this, then we can draw a table quickly. You can say part, then we can say Z curled, which is in millimeters. Then we can say volume, which is in millimeter cubed. Then we can say Z curled volume, which is in millimeter to the power 4, right? Great. So there we go. Table. We draw a table quickly and then enter all the values that needs to be entered. Great. We have how many rows? 3. So we have 1, 2, 3, and then for summation the fourth one, like so. Okay, there we go. Great. So we have part 1, part 2, part 3, and summation. And what we have for z cubed bar 1 is a 56.25. Then z cubed bar 2 is 200, and then z bar cubed 3 it is 475. Volume 1, we said we are supposed to assign it a negative. Okay, so minus, because it's a hole that has been created at the bottom of this cylinder. All right, so 70 all right, so 7068 583.47. Okay, what's volume for the second one is 28,274,333.88. Volume for the third one is like for the first one, but we are going to subtract it, right? We'll need to subtract it. Great. And let's get the products. The product of these values. So 56 point. So for these ones, I'll just write them as products, right, like so. Okay. Then I'll just sum them in the calculator, because I extend these lines, right? Maybe I extend these lines because we don't have space. Okay, I extend these lines just a little bit. So product, I'll just get them in the calculator. 56.2425 by minus 7068 583.47 as a product, and then the other one is just a 200 by 28 27 43 33.88. The other one is 475 product with 7068 583.47. Okay, let's do that. 56, we sum them up, we do the product. 56 by minus 7068 583.47 plus 200 times 200 times 28 27 43 33.88, and plus 475 by 7068 583.47. Okay, so we have the final value of 861.836 104. A huge number. Okay, then when we sum up the volume, just 20, the 2 will subtract, this and this will go, then we'll just remain with the 28 27 43 33.88. All right, Then the z bar is equal to summation over z curled v, all of them, as from n equal to 1 up to 3 divided by the total volume. This is equal to 8,614,836,104 divided by 28 2743.88. Therefore, our Z bar is equal to 8,614,836,104 divided by 28,2743.33.88. Okay, so we have a 304.69 millimeters. Alright, let's show it here. Let me outline this final solution. Let's show it here. So we are saying it's 300, and so it's going to be somewhere here. Okay, to be a little bit on top somewhere there. Okay, somewhere there, right? So this is where it is. So this is our Z bar, which is equal to 304.69 millimeters. Okay, I think it makes sense, right? So I hope the video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and see you in my next screencast.